So I want to welcome you to Joan's seminar. I don't think I've ever introduced a Joan seminar before, ever. I'm Eric Fossum, and it's my great pleasure to introduce our speaker today, Dr. Victor Lawrence, currently at the Stevens Institute of Technology. Victor is originally from Ghana, but went to school in London for all 3 degrees, and then was immediately recruited from graduate school to AT&T Bell Labs, where he spent his entire career up until the time that he went to Stevens. At Bell Labs, he, of course, performed technical work, I guess as a member of the technical staff, and moved up through the ranks, becoming vice president of Bell Labs, which is no small rank for sure. And during his career, he worked on a number of different technical areas, and kind of one of the areas that he was involved with was fiber optical communications and undersea cables, and he's going to tell us about his adventures there. I will also, his adventures there and after Bell Labs in particular, but I will also like to say that Victor is a member of the National Academy of Engineering. He is a fellow of the National Academy of Inventors, and I'm very, very happy to say that in a mere 12 days or so, he'll be inducted into the National Inventors Hall of Fame in Washington, D.C., which I will also attend. I'm really looking forward to that. So we are really lucky to have Victor. I invited him to come up, and he was willing to sit on the Dartmouth coach for whatever it is, half a day, and come up, and he'll be doing that tomorrow, going back. And so it's always great to have somebody venture up into the woods here to come talk to us. So with that, take it away, Victor.
Thank you so much. Thank you so much. Can you hear me? Is it? Yeah. I think he's taping it, so I wanted him to. Is it coming out clearly on the tape? Yes, he's filming it. Okay. So thank you so much. It's a pleasure for me to be here, Eric, and thank you so much for the wonderful introduction. And then also thank you so much for helping me nominated into the National Inventors Hall of Fame. What you don't know is that he's on the committee that decides. And somehow or the other, he allowed me to slip through. Anyway, so thank you. And to me, this is my very first trip to Dartmouth. I've been here in this country for over 30-something years, I guess since '74. I've never had this opportunity. So thank you for giving me this opportunity. I'm here really to tell you about some interesting things that I'm doing in Africa. And I'm really here to ask for help. Ask for help in the sense that I believe that you folks can come up with inventions and innovations that can really lift up the continent. And so as you listen through my talk, you may find things that you can contribute to. And I will be very, very grateful to take down your name and your ideas. So, you know, in this world, most of the time, and especially me, when I was at Bell Labs, I was doing inventions, but I never thought of the other 3 or 4 billion inhabitants out of the 7 billion people on this earth. What type of technology do they need? And therefore, we'll talk about the challenges, how we can bridge the difference in the digital divide. So I'm going to talk to you about some of the appropriate technologies, and I'm going to challenge you to come up with solutions for us. The United Nations last year came up with what they describe as their Sustainable Development Goals. And this, all 192 countries of the United Nations signed this declaration. And they had these 17 goals, but there are some that are of importance to us. Goal number 3, for instance, is good health. And I challenged you and I said there is many things that you can be working on that could help with good health. And number 4 is quality education. I also think that there are many things that you can think about that can help with quality education. Number 6, it's clean water. That's something else too. Everybody needs clean water. Without clean water, you can never survive. But there are people on this earth that do not have clean water up to date, and there are billions of them. Number 7 is, this is better, affordable clean energy. Of course, energy is very important for us. And then when people say it's affordable, but clean, some people don't worry. They just want energy. But of course, clean is because of the because we want climate change. And then I think number 9 is industry infrastructure, and that is something that I will keenly focus on. And number 11, it's smart cities, sustainable cities. And you see through my talk that at the end, that I'll be focusing a lot and asking, can we have a smart village? Can we have a smart city that can address the problems of these 3 to 4 billion inhabitants on this earth that do not have the appropriate technology? One of the things that the African Union did was to form an organization called NEPAD. And NEPAD is the New Partnership for Africa's Development. And it consists of all the African Union, 54 African countries, and the G7 countries. So they meet regularly. The G7 countries, the rich countries, meet with the 54 countries of Africa, and through the auspices of NEPAD. And NEPAD is like the United Nations Development Program. And NEPAD does almost all the programs, or tries to encourage the programs for Africa's development. Well, as you can see, there are a number of things that are very important for developing countries. Agriculture is, health is, education is, of course, business and government. And good governance is one of the key things. And so we look at these things and say that we have to promote technologies that will have an impact on these areas. Impact on government, impact on education, impact on health, impact on agriculture. Let me give you a few statistics. Africa is really very well underserved. And as you can see, the penetration of internet is very small. It's only about 28%, whilst the rest of the world is about 49.7%. So we need a lot of catch-up to do. And some of the technologies I will describe this afternoon will be helping and speeding towards this catch-up. Education is very important. And you can see some statistics here. The less than 65% of folks in Africa, Sub-Saharan Africa, have a primary school, complete primary school education. In secondary schools, less than 25%. And in fact, higher education, tertiary, it's just about 5%. And we have a shortage of about 4 million teachers. So we have to train very quickly 4 million teachers. How do you do this? Well, of course, you know, for education, one of the priorities is to have e-schools so that we can have computers and computer education in schools. And so we like to have a lot of training on computer-based learning. You also need a teacher, but most teachers may have limited opportunities, so we need to train teacher aides. And it will be easier to train those teacher aides. So we also like to involve groups of students in productive ICT tasks. This is a big challenge, so that we can have the teachers dealing with a large number of students. We have to do this. Healthcare is another problem. You know, Africa, although it's only 12% of the world population, we are encumbered with 25% of the world's disease. And of course, we only have about 3% of healthcare workers. We need to boost this up. There are about 36 million people worldwide who are living with HIV. And out of the 36, 25.8 million is in Sub-Saharan Africa. So we need things that we are working on, not only trying to prevent this, but even vaccines and so forth that most of you are working on. I think I talked to Professor this today that is having some ideas on how to be able to work on these problems like vaccines and so forth. Look at what happened with the Ebola cases. And what you look at, you will see that in the population of about 800 million people in Africa, there's one doctor for every 10,000 people. In Europe, you have one doctor out of every 350. So you can see the dimension of the problem. This is no exaggeration. The problem is there, and we have to find solutions. And the solutions relies only also on us, but also in the universities like yours in the advanced countries. This shows the number of the EVD is Ebola virus diseases, and the blue line shows, and well, in here you have various countries and the various diseases that happened. Some were very lucky. I mean, you take UK, USA, you had 4, but there was only 1 person that died, whilst you have many cases in Sierra Leone, Liberia, and Guinea. So I say that we can really improve the healthcare through ICT, information and communications technology. And this ICT has the potential to help with the healthcare delivery, and it also has the potential to be able to help with evaluation of patients, to be able to follow up patients, and have electronic management records, which we do not have today in many cases. Healthcare also is something very important that we can do. But there is one thing that I can talk about. The last bullet item, remote facilitation for surgery and other medical procedures. I dream that one day a patient in Africa or in Asia, in underdeveloped regions, may be able to have a surgery done by a surgeon in the United States. And how can you do this? And we hope we can do that with communications technology. So these are some of the things that can help. As well, we are training the doctors, but at the same time, we can be able to reach out to some of the advanced countries and be able to see whether they can help with their healthcare problems. Agriculture is another important thing, because agriculture, that's the part that gives us the food. And so there are many things that ICT can do. ICT can help with market information to the farmers, so the farmers can know things in advance, so that they can know when to deliver things so that they don't have perishable goods. Local weather reports, so that we can look at the weather reports and know what is going to happen. Transportation is something else that you can do with agriculture. And you can give advice on current crop informations and livestock informations. So these are things that can help with agriculture. But most important is good governance, because you always hear these problems that Africa has resources, but its resources are being wasted because because we don't have good governance. So this is something that ICT can help. With ICT, a lot of the things that you need for good governance can be documented and can be passed on to the citizens. So improvement in good governance is something that we are also looking for. Of course, the most important thing is human resource development. So this is something that we hope ICT can help. I hope someone in Africa can take courses in Dartmouth. Somebody in Africa can take courses in Harvard. I know these are difficult things, but things like degree programs, I know it's very difficult to have someone award a degree without having been present. But maybe we can find a way in which ICT can help with this as well. But simple things that you can do is visits, internships, workshops. These are things that can help education and human resources development. So you can visit African universities, you can visit African schools, you can have workshops. Africans can come here for workshops. So these are things that can help with the human resource development. Support doctoral research is something that is important. In the sense, I mentioned this because we really want appropriate technologies. We want to have PhDs that are addressing appropriate technologies. That will be the needs of the developing countries. So you can see human resource is something that you can contribute to immediately yourself. You can get on a plane and visit, give a talk like I'm giving a talk here. So there are many, many things that you can do. Now, I looked at this situation. I know that it's difficult, but I'm never discouraged about this. I know it can be solved. So when I was in Bell Labs, I thought that one of the difficulties that Africa has is that it did not have enough communication between Africa and the rest of the world. And I've just put up something here. In 2007, when I left Bell Labs in 2006, I looked at this in 2007. This is the submarine capacity that is going on. And you look at it, and you say that from New York to Europe, there is 12 terabits available of capacity. From Los Angeles area to Japan, there's 8 terabits. And you can just go around. But just look at Africa itself. On the West Coast, there is just 120 gigabits per second. On the West Coast, 130 gigabits per second. This is small. So it's been very difficult for people. It was difficult for people in 2007 to be able to communicate with the rest of the world. So I took it upon myself and said, what can I do and what can we do to do this? I know that when I was in Bell Labs, AT&T started a project called Africa One. That was in the 1990s, in the 90s. But that project did not take off. But Africa One was putting a submarine ring around the continent of Africa. We did the appropriate technologies that could address this issue. But came 1996, AT&T was divided. There was a travestiture. It was divided into 3 separate companies. The service part, AT&T, the equipment and manufacturing, and the research part, which was Bell Labs and Lucent. And of course, there was the computer part, which was NCR. So this project died. Again, after in about 2002, 2003, I was still in Bell Labs, and we tried again to see whether we could do this. But then came the collapse of the many companies and the financial collapse around that time. So we had to put it on the shelf again. Then in 2006, when I left AT&T, the African Union called me immediately and said that they think that this program is very crucial and important. So there were two presidents. One was Mbeki of South Africa, and the other one was Obasanjo of Nigeria. And so they started working with me to see what we can do about submarine communications and communications from Africa to the rest of the world. Now, you know that's something very interesting. Now, I'll tell you when I get there. So we know that we have the digital divide completely between the haves and the not haves. The rich countries, Europe and Americas, have 12 terabits. Africa and some Asian parts have less than a terabit. But you know, when people talk of digital divide, you can talk about digital divide between the rich and the poor countries. But even in the rich countries, sometimes you can have a digital divide. In the US, for instance, there's difficulties between urban and rural, or between high-income and low-income groups. Of course, here we talk about the developed and the underdeveloped regions. So there are those problems as well. So the digital divide between developed and underdeveloped countries exists, but even in the developed countries, it exists between the rural and the urban areas. Because not all the, and the reason why internet is so important is that you have slow dial-up if you don't have any internet access. Children cannot be able to complete their homeworks on time, and graduating students have a lack of digital skills, and therefore they have poor access to jobs. So it is important to tackle ICT and have everyone have good access to the internet. Now, this gives you an example of the internet adoption. The good thing is that it's increasing all the time. Look at it, started in 1995 with about only 14%. Now we are at a very, very high level. This is not Africa. This is the rest of the world. Yeah. So this is increasing all the time. This is an example of the rich and the poorer areas of the United States. But let's focus on the Africa and the rest. Now, this curve, you have to look at it the other way. You know, if you Myanmar with 99.5%, it doesn't mean that it has maybe only 0.5% internet connection. So you read this curve the other way, is where most people don't have internet. Okay, not where most people have internet. So you look at it this way. You see United States is only about 84% only about 15.9% of the people don't really have internet. Brazil, Egypt, you can keep going on. But you can see there, Africa, Ethiopia, nearly only 2% of the people have internet access. Tanzania, only about 5%. Democratic Republic of Congo, only about 6%. Bangladesh, Pakistan, it goes on and on and on. So there is a difference between the haves and the have-nots when it comes to internet access. Can we change this? And I think we can. So when the IEEE heard that I was coming to give a talk here, they specifically asked me, they specifically gave me 3 view graphs, and they insisted that I should show them to you. So I'm showing them to you. And they wanted me to tell you about IEEE because they are doing some things in Africa and some of the regional. So I hope that most of you will like to join the IEEE, and I hope you do join. But they wanted me to show you this. They have 420,000 members. They have 47 societies. They are in 160 countries, which is great. There are only 192 countries in this world, and so there's only 32 that they are not accessing. They have a lot of annual conferences, and they have a lot of periodicals. So this is the IEEE. They wanted me to show this. And they are really engaged in a number of things worldwide. And they have a philanthropic organization, the foundation. They want to improve human conditions, and they also want to preserve the common heritage. They want to empower bright minds, but most of all, the reason why I'm showing this is they have something called IEEE Smart Village. And what is the Smart Village doing? The Smart Village is helping with power, for instance. So they've gone to more than 34 villages to help with the power condition there. And they are improving and continuing. So they wanted me to show you this. But I'm showing it because I know that power is one of the important things that we need. So let me come back to my information, the capacity. So we started working on this in 2007. 2016 now, we have been able to put a lot of fiber optic capacity around Africa. And in the particular project that I worked on was on the west coast of Africa, called ACE. And you know, this is a $700 million project. And no country can afford it. No African country can afford it. Even in the United States, if you tell somebody to give $700 million, the country they will question it. So how do we do this? So the first thing we started doing with the Charter of the African Union was that every country should be connected. So I started this, and I had to go country by country along the West Coast. Each country had its own thing. And you can see that in each country, I will go and be asking for 25 million. 25 million is a piece of cake for some companies. But they could not afford it. Countries like Liberia, Sierra Leone, Guinea, and others, we had to go to the World Bank to ask for help. And so the World Bank gave some money towards the 25 million for that company. But you can see, if all these countries are contributing 25 million each, we eventually have the 700 million that we require to be able to build the cable. And there are difficulties because this cable has to be shared. So every country is sharing this cable. So it means that you have to make sure of the diplomacy, that each country, this country says, oh no, I don't want this one, I don't want this person, those things have to be solved. So we had to solve those and assure them that their communications are secure by this design that we come up with. So you can see the list of this. And when you go to a country, you may have to go to one or two telephone companies in the country so that you can ask them to be part of this consortium. And then for if it's 25 million, maybe they pay 10 million each, or they can borrow some money from the finance development institutions. And so we embarked on this in 2010. We started building the cable. Now, let me see. I have a film to show you. This is the submarine cable. But let me show you how we were constructing it. Is it loud enough? Yeah. A stands for Africa, coast to Europe. And we started in PMI in France, coming through Spain, and then going through Africa. It's 17,000 kilometers of cable, and it connects more than 20 countries. These are some of the flags of the countries in the various. Okay, so continuing. This is a summary of what you just heard. 17,000 kilometers. We haven't finished this. In 2012, December 2012, we completed 12,000 kilometers. That is going from Penmarsh in France, that's number one, all the way to an island called Sao Tome. And that was 12,000 kilometers. Now we are building the next one, and we hope to finish it by 2017, going from Sao Tome all the way to Cape Town. And we have 22 countries in all. And so we have only 5 kilometers remaining. There were some of the countries that never had a cable. And they were countries that had a lot of problems, like Liberia, Sierra Leone, the Gambia, Guinea-Conakry, Equatorial Guinea. You can count, there are about 7 of them never had a cable. And but now that they have it, we are seeing improvements. And so you can, let me just tell you a little bit about the technology that goes with this. The EE folks would like to know about this. This is fiber. It's the size of your hair. But you cannot just put the fiber on the ocean. The mechanical engineers have to be involved. See, this whole thing has to be hardened. And of course, the electrical engineers and this are involved in the lasers and the different colors of light. You see, if you take a cable like this, you can have the asphalt stoke yarn 7 at the end to harden it before you can put it under the ocean. So we had the mechanical engineers involved, the electrical engineers involved in the fiber. Now, and then the question is, how far can you go? And there are 2 technologies that have come to being. One is TDM, and then the other one is wave division multiplexing. And that is the key to this whole thing. Wave division multiplexing is this, I will be asked is, how many different colors of light? You know, a laser can carry many different colors of light. And in this, the technology allows us to have about 128 different colors of light, 128 wavelengths. Now, each wavelength can carry so much, and therefore, it looks at how many bits can you put on a wavelength. So now we are at things like, what I mentioned, 12 terabits per second of capacity. And it's even increasing more. And it has been going about 100 times per decade. We are improving this 100 times. So this is the engineering part. How do you multiplex many different colors of light? So this shows you a chart. You multiplex many different colors of light on the far right. And of course, you do it in an orthogonal way. So there will always be 2 dimensions. And then, of course, lower here is the various modulations that you can put on each wavelength. Here there is 16, that's 4 bits. So you can put 4 bits per wave. You can put 4 bits, but that 4 bits will have to go on one wavelength. So this is the technology, and this is what we call the modem technology. That is in optical fibers. And these are things we had to work on. I worked on this when I was in Bell Labs. It took a long time for us to do the manufacturing and get this into the field. But now we can have 28 different colors of light. Each color of light, you can pulse each color of light at 100 gigabits per second. Can you imagine this? Putting on or off a light at 100 gigabits. In 1 second, you can put it on and off 100 gigabits, 100 giga. So this is the technology behind this. And of course, another technology that had to come into being is that when you are under the ocean, you have to ask yourself, how far can I go before I amplify the light? And that is also one of the facts of the things and that depends upon the capacity, the spectrum of that. So we had to work on that as well. And then, of course, at the end is where you do the repeaters. So normally we can go 350 kilometers before we have to put an amplifier up. And so you can count the number of amplifiers in the 12,000 kilometers. Now, okay, I've been able to connect these things, but let me mention one quick thing. I'll be finished soon. Let me mention one quick thing here. You see these countries. I'll give you an example. Before this line capacity, and normally, let's forget about satellite for the time being. But before this capacity, if you want to go 130 miles from the capital of Accra to the capital of Togo, which is 130 kilometers apart, you have to go to London and switch from London to Paris, and switch from Paris to come to Togo. Now, this was costing the African countries $600 million a year. But when you go to them and tell them that, look, this is costing you $600 million, I only need $700 million to do this, it was a tug of war. They said they didn't have it, but they were still paying the 600. That's one thing I wanted to tell you is the advantage. Not only am I getting communication from each African country to Europe or Americas, I'm getting communication between the two countries on the fiber. And that requires me not to go to Europe for switching, and it's cheaper. So now, there are places where fiber cannot go. So what do we do about places where fiber cannot go? Maybe you still have to use satellite. Maybe you still have to use wireless. So you may have to use some wireless technologies in the interior parts. Well, and in the satellite, there was a problem because you have to go so many, the satellite, you have to circle around the geosatellite. And the distance was very long, and so it gives you lower capacity. But a company came up, I don't know how far they are doing, it's called 3B. In fact, there were those I stole this idea from. The 3B stands for other 3 billion. They say that their satellite is in the medium Earth, and it can work for the other 3 billion. As you can see, the problem is not in the developed countries. They only have less than a billion or so people. The problem is in the developing countries, where they have the 6 billion or so people. Now, so now we are looking at how to use satellite in the interior and fiber optics at on the ocean to Europe. And of course, these are advantages. Satellite, the latency is high, the throughput is small. Fiber, the throughput is high and the latency is small. And this company, 3B, said they were going to go in the middle between geosatellite and fiber, as far as delay is concerned. So let's get back to why we started doing this. The UN Development Goal says we should try and work on e-health, e-schools, and e-commerce. I gave you these statistics earlier on. I just wanted to repeat it. In Mozambique, 2 doctors for 100,000 people. So these are some of the statistics that you do have. They are very dismal. I mean, there are countries like South Africa, which has nearly 70 doctors for 100,000. It's one of the more advanced countries. Ghana, where we come, we only have 9 doctors per 100,000 people. And the statistics is so for all the others. You can get this in the World Health Organization statistics. Okay. So what does Africa have? Africa has the sun. So what is the appropriate technology? Can you help, instead of people using wood for cooking, can we have solar for cooking? And this is something that is possible. And there are many, many different kinds. You can have a parabolic, you can have the box type, all are capturing the heat for cooking. And this is very good because you no longer have to be absorbing the smoke when you use coal or wood. Water is another important thing. And what can we do? What do you do about water? The only way you can have is, everybody needs clean water. If you don't have clean water, you have diseases. If you don't have clean water, you cannot even wash your vegetables. So with water, what can we do? The only way is to use solar pumps. And there again is solar. So solar technology is very important. So we can have solar pumps, and they can drill and pump the water. And so these are examples of solar water pumping projects that we have in Africa. And we are using solar for the vegetation over here. Another important thing is schools. What can we do about ICT for our schools? You know, there again, I've been digging around, and I found a system in New Jersey called the New Jersey Center for Teaching and Learning. They've been able to have a groundbreaking thing, indeed. And I can show you their statistics, but they first change things. They teach physics first before they teach chemistry, and they teach biology. Most schools here teach biology first, then they go to chemistry, and they go to physics. But they believe that teaching physics first gives you a better understanding. So physics first. Now, 12 schools, these were tried. This has been tried. And the results came out in New Jersey. And out of 12 schools in New Jersey, their schools came in the top 12. 6 of their schools were in the top 12. Now, you looked at where their schools are, 60% were in the poverty areas. And the other 6 groups, they only have 4% of poverty. You had black and Hispanics were 70% of that school. In the other ones, which were the 6, you only had 8%. And they were in the urban districts, Newark, Patterson, New Jersey, etc. So I took these people to Gambia, the Gambia. went to the World Bank, got a World Bank grant, and went to the Gambia. I helped them get to the Gambia to teach, and they are getting great results. And so Gambia is now adopted this whole thing, and hopefully it can be adopted in the rest of Africa. But the thing is that they are training teachers and the students for math, physics, and sciences at a faster rate. So these are some of this. Now, so another challenge I throw to you, apart from solar power and all this, maybe you should think about a smart city or a smart village for Africa. A smart village where you don't, where you have ICT and other things, but it will become much, much easier. So this is a concept that I have about infrastructure for smart cities for Africa. And this is a challenge I would like you folks to work on. This is by no means the end of it. It's just the beginning. So I throw you that challenge. And these are some of the things that you can tackle. Crime, disaster, emergencies, waste management, smart learning, smart farming. It can go on and on and on. So we can have a smart Africa, a smart village, or a smart city. Another thing too I can throw is that maybe we can go to the philanthropists and ask them to give grants to be able to buy capacity, submarine capacity. So this is something that I'm working on. There are 12 foundations that are very much interested. Carnegie Foundation, Ford Foundation, etc., etc. So I'm trying to get them together to pool their resources so that we can buy capacity to distribute freely to the schools and the universities and hospitals and other places. So I think I will end here and ask you if you have any questions. So what we are doing, well, there's one thing too I should mention. You know, I've mentioned that we are talking about saving lives. You know, the network I looked about there, every time I worry because of cybersecurity problems. And of course, if one country is not happy with the other country, it may start maybe not war. You can even have physical war, but it may start a cyber war, which means my whole cable will collapse. So yeah, so that's something else you can help with. Mm-hmm. Yes.
There are perhaps 50 countries in Africa,
Yes.
many of which I suspect do not want education. So you're facing a massive task of education for the continent as a whole. How much of a barrier is this to you?
Yes, it's a big barrier, but we hope that information technology and access to the internet can help educate them in that way that they should have education. No, they complain about this because in the farm, if you let people go for education, there will be nobody working on the farm. So this thing comes up over and over and over and over again. So some of them don't help, but we hope that with information, they can be able to browse the internet and see what is happening in the rest of the world. So we have that problem to solve. There is no doubt. Mm-hmm. Yes, sir.
How do you go about penetrating bandwidth interior to the countries as opposed to just connecting along the coast?
Okay. We do not have a solution except to go wireless and satellite, because it's very hard to put fiber optic things down. So we have to improve our wireless technology, we have to improve our satellite technology, and be able to have a network that can multiplex all these things and put it on the fiber optics and ship it. And if we can do this, and if Dartmouth is willing, Maybe you can let some people take some courses from Tanzania, from Ghana, from this on your internet courses. So we have to use wireless. We cannot do any other way. In fact, there are many other things. I believe that, is it Facebook? He was talking about balloons, putting some balloons in the, some people are saying, oh, maybe we can have drones, and drones flying, so they can pick up the information. But there are many things. But I think if you put your minds to it, great minds like the ones in this room here, great minds like the ones in Dartmouth, if you put your minds to it, you may be able to solve some of these problems. And the one that you asked, how do you really do it? James, you had a question? No?
Sure. Full disclosure, Victor was on my doctoral committee. I just finished a PhD last year, so this is a bit of a softball, a little bit of softball. My field is socio-technical systems. Obviously, the problems are not just technology problems; they're social issues. What if they don't want something? How do you make the social side and the technical side? And personally, I've had tremendous difficulty getting an academic appointment because I'm interdisciplinary. Right? Our academies parse the knowledge of it to discipline specifics, not just schools, but even within the schools in very specific disciplines. But the world happens in systems. That world doesn't exist in such neat boundaries. And if you do problem-directed research, it tends to transgress those boundaries immediately. So the question behind all of this is, if anybody has a suggestion for me in this regard, how do you get systems approaches, which is how the problem comes as an integrated system, in academies that are so silent? And I'm all ears.
You came all the way from Cornell to come to this talk.
Yes.
Back to Cornell today, but I'm a visiting scholar at Cornell, and I drove up from Boston. That's why.
I think Dartmouth will have an answer to you because of what I heard today, talking to a number of you. That is that all right? You do interdisciplinary things. They don't even have departments. Okay, yes.
I can give one answer, which is that I spent a year in Washington at the State Department promoting exactly what you're talking about. This was the same year, 2007.
Yes.
And it's interesting to me that every word you had on your slides was the same thing that we had on our slides.
Right.
Trying to get AID and other people involved. But the State Department and other government agencies really do look at these as systems problems, and there are positions in the government for PhDs working on systems internationally, and it's something to think about not only for you, but for engineering students who decide they really don't want to do research and they don't want to start a company. There's some wonderful opportunities in Washington for people that understand these issues.
When you talk about building solutions to fix the infrastructure or development infrastructure, who do you think, or how do you think this should be funded? Do you think we should rely on governmental organizations or NGOs to fund this, or do you think the focus should be more on building sustainable business models to build these?
It's to really rely on the sustainable systems. But what is needed is public and a private partnership. You need that. The private sector has to be there. The public has to be there. And the public has to provide some resources, even if they're only giving land. Even if they're only giving this classroom for the school. So you should have a public-private partnership, and that is the only way to lift these developing countries. But if you go back to the United States also, I'm sure there were times when you had public-private partnerships. I know the Department of Agriculture, when you were doing electrification in rural, they had all these partnerships.
Yeah, that was very strongly pushed by the Republican group in Washington, i.e. George Bush, really pushed that.
Public-private partnerships, you really need that.
And my experience with NGOs has not been very positive. They tend to jump into a place, do a project, and then leave without making sure that that project will continue. And so not only do they not succeed, they cause problems after they leave because they depress the people. I have a word I've invented for that. It's called a detribution.
Yeah. Well, we need to work on the NGOs and make them more appropriate. Just as I'm talking about appropriate technology, I should be talking about appropriate NGOs, what their roles should be and how they should be answering things and addressable. But your point is very, very well taken. You must have sustainability. That's why the UN mentioned Sustainable Development Goals.
Okay, well, I think we should thank Victor one more time. I just want to say that we have a long list now of things that we can work on to help the other $3 billion. So
That's
thank you, Victor, for that.
Thank you so much.